Hello class, we have loads of examples for you today. We don't have a lot of notes, just really examples, because most of what we're talking about you already know. We're just combining it all together. Today we're going to talk about linear equations, but also comparing functions. So go ahead and put your information in your heading. You're in either period 1 or period 2, and today's the 13th. Happy Friday the 13th, and happy High Five Friday. Sorry I can't be there with you. Today we're going to look at how do we compare key features of different functions. Most of these will be linear functions. I did throw in one exponential to see how you do with it, but I think you'll be just fine. Alright, example 1. Let's say we have Tara comparing the slopes of two different functions. Function f of x, as displayed in this table, and she wants to compare that to the slope of g of x right here. Okay, well, in order for me to compare slopes, I need to know the slopes of both of them. So I'm going to find the slope of g first. You can pick any 2 points on the line you want. I'm going to choose this one and this one. My rise is 2. My run is 1. So my slope for this line is 2 over 1, or 2. Alright, and over here at my table, I can see to get from here to here, I'm growing by 3. I know because I'm getting more positive. And from here to here, I'm growing by 1. So my slope here, my rise over my run, or my f of x over my x, is 3 over 1, which is 3. What is the slope of the function with the larger slope? The larger slope. Well, 3 and 2. Which one's larger? 3 is larger. So my larger slope is 3. Alrighty, how about another example? We have another person now, Sky. She's also doing the same thing. She's comparing a table, but this time she doesn't have a graph. She's comparing it to this function right here. And you can go ahead and pause the video and read it and go as slow as fast as you like. You can go back and rewatch to your needs. Alright, this time I'm trying to figure out what's the value of the smaller y-intercept. Last time we were looking at the larger slope. Now I want the smaller y-intercept. Maybe you would want to label that one M. Over here, I'm thinking my y-intercept is B. Alright, to get from here to here, it's getting more negative, which means it's going down by 2. Over here, it's going up, up by 1. So my slope over here, is rise over 1, negative 2 over positive 1 is negative 2. Oh, but look I made a mistake. It's asking me for y-intercept. So, is this helpful? Well, it actually is, because it's not asking me for the slope, but I still need to be able to figure out the y-intercept. So this is where I'm going to have to use, I might even need more space, and I don't really have the space on here, and my video is kind of small, so I'm going to go ahead and add some extra space right here. You can always use extra line paper if you need more space to think about my equation. So I know my equation, y equals mx plus b. I know that my slope is negative 2. And I don't know anything else, but I'm given tons of points. So I could pick whichever one I want. I would pick the one that looks the easiest for me to work with, and in my opinion, that's 1, negative 7. So the point 1, negative 7, 1 is the x value. So for x, I'm going to put 1. Negative 7 is the y value. So for y, I'm going to put negative 7. And now I know everything except for b, which is great because now I could solve for b. So I have negative 7 equals negative 2 plus b. Add 2 to both sides, add 2 to both sides, sides of my equal sign. This cancels and I'm left with b alone on this side. Negative 7 plus 5 is negative 5. Cool. So my y-intercept is negative 5 here. Let's keep that in mind. My y-intercept is negative 5. When I look at this equation, well, it's not in slope-intercept form, so if I want to find the y-intercept, I need to put it in slope-intercept form. I need this y alone. So I'm going to subtract 2x on both sides. These cancel. I'm left with negative 4y equals, I'm going to put this one over here so that it's closer to slope-intercept form. Divide by negative 4 on both sides. Uh-oh, running out of room. Whoops, sorry. Sorry about that. These cancel. I'm left with y equals, this negative 4 belongs to both with them, and unfortunately I'm going to move over here for more space. I'm left with y equals Negative 2 divided by negative 4 is positive 1/2. And 16 divided by negative 4 is negative 4. My slope and my y-intercept. This problem asked me about y-intercept, so I'm comparing negative 4 and negative 5. I want the smaller y-intercept. Well, if I'm thinking about smaller, that's farther to the left on my number line. And actually, even though my gut tells me negative 4, when I really think about it, I know that negative 5 is actually smaller. When I think about debt, I have less money if I have negative 5. So negative 5 is actually smaller. So I've got A right here. Feel free to pause this, restart it, if you need to go look at some more examples of how to put this in slope-intercept form. We did that last week. So you're more than welcome to, if you need, turn back into your notes. On page, what page? On page 45 in your notes, if you need to see more examples of putting something that's not in slope-intercept form into slope-intercept form. Or you can also look at page 51 for how to find the slope and y-intercept with different types. All right, we're gonna go ahead and look at a few more examples. I know it's kind of a lot, so like I said, you can always stop it, rewind, pause it as needed. I would pause, fill out the parts you want, go back, pause, play, and then keep watching when you're ready. Example 3, we're now comparing a graph and some data. So this one's kind of hidden in here. It says this one's h of x. And it says compare the slope of function g, and g has an x-intercept of 4 and a y-intercept of 6. That's kind of hidden. An x-intercept of 4 and a y-intercept of 6. X-intercept of 4 would be right here. Y-intercept of 6 would be right here. So really they're giving me 2 points in a hidden form. So y-intercept of 4 would be 4, 0, and an x, oh, excuse me, that was my x-intercept. And a y-intercept would be 0, up 6. So really I have 2 points, which means if I have 2 points, I can find the slope, and then I can find the y-intercept. Or if I have 2 points, you're more than welcome to use your calculator, and you can absolutely do a linear regression. But I'm going to do it out in case you don't have your calculator. So I have my, for slope, I have my rise over my run. So I'm going to go ahead and call this x1, y1, x2, y2. Sorry, there's some students out in the hall. I'm going to take 0 minus 6 over 4 minus 0. I get negative 6 over 4, which is really a slope of negative 3 over 2. And then similarly to how we did this one, I could go ahead and take that y equals mx plus b, where I don't know my b, but I do know a point. So I can use my x and y values to put in for my x and y values. Y is 0, x is 4. When I multiply this out, I get, need some more space. Let's do that over here. I have 0 equals negative 3 times 4, which is like 4 over 1, is negative 12 over 2 plus b. 0 equals negative 6 plus b. Add 6 to both sides. I'm left with b equals 6. But you know what? I just realized I was a little silly, because if I read the problem clearly, it says, what is the slope of the function with the larger slope? So I just found all this work to find my y-intercept, but really I didn't need it. I could have actually stopped right here at slope, which is really actually important, because if we don't read directions, we end up doing either extra work, or we might even have the wrong answer. I might end up getting something that was wrong because I wasn't reading. I just jumped right into this problem. So I'll use me as an example of not wanting to just go ahead and solve right away, but actually read what it's asking. So I'll keep this here. Maybe I'll refer back to it later, but for now it just asked me for slope. So let's go ahead and compare this slope and this line. I'm gonna pick 2 points. How about that one and this one? And I went down 2 to the right 1. So that's the slope. Down 2 to the right 1 is -2/1, which is -2. So I have these 2 slopes and I have to compare the larger one. The larger one I think is -2, but when I think more closely, -3/2 is really like -1.5, which absolute value is less, but actually that's more positive on our number line. So this one's actually larger. All right, those are 3 examples. I will put a second video that has the rest of the examples in your notes so that you can go see a few more examples if you're still feeling like you want to see some, or if you get to today's classwork and you need some more examples.